So today's lesson, 11.4, area of regular polygons and composite figures. We will spend 2 days going through lesson 11.4. So first of all, let's talk about some definitions. The center of a polygon is the center of the circumscribed circle. So you actually have a hexagon here pictured. The center of the hexagon is actually the center of the circle that is circumscribed about the hexagon. Remember when you learned the definition of circumscribed, you learned that if a circle is circumscribed about a polygon, every vertex of the polygon is on the circle. Okay? The radius goes from the center to the edge of the circle, and it's also known as going from the center to the vertex of the polygon. And then we have the apothem. Now the apothem, we represent that with a lowercase a, is the perpendicular distance from the center of the polygon or the circle to the side of the polygon. Perpendicular distance. So the first thing that we're going to do is look at a hexagon, and these are regular polygons. So maybe it's a good reminder to talk about what a regular polygon is. Remember that regular polygons have congruent sides and congruent angles. That might be important to remember. All right, so each regular polygon has a radii. So I'm going to color the radii green so you can see them. It also has apothem. That's this dashed line right here. We are going to find the measure of each numbered angle. So let's look at the measure of angle 1. So if you didn't remember what kind of triangles are made inside of a hexagon, you could actually circumscribe a circle about this hexagon and then go ahead and count how many angles are there. 1, 2, 3, 4, 5, 6. So 360 divided by 6 is 60. So the measure of angle 1 is 60 degrees. Well, hopefully you also remember that a hexagon is comprised, a regular hexagon is comprised of 6 equilateral triangles. But if you did not remember that, you could look at this. So if angle 1 is 60, angle 2 would be bisected, so half of 60, the measure of angle 2 is 30. And the measure of angle 3, remember this is an equilateral triangle, is 60 degrees. So we're just looking at the shape and determining angle measures. All right, so our next example, before we start it, we have to talk about how to find the area of a regular polygon. So the formula for finding the area of a regular polygon is 1/2 times the apothem, represented by the little a, times the perimeter of the entire shape. All right, so the perimeter of the regular polygon. So for example number 2, I have to find the area of a regular polygon with 20 12-inch sides and a 37.9-inch apothem. So I know that the number of sides is 20. I know that the side length is 12, and the apothem is 37.9. What I don't know is the perimeter, but I can find it, because I know the perimeter all the way around is the number of sides multiplied by the measure of each side. So the perimeter is 240 inches. Now I'm going to use that and solve for the area. So the area of this regular polygon, 1/2 times the apothem, 37.9, times the perimeter, 240. So the area equals, so in my calculator, 0.5 times 37.9 times 240. 4,548. 4,548 inches squared. Please do not forget your units. All right, example number 3. A library is a regular octagon. Each side is 18 feet. The radius of the octagon is 23.5 feet. We have to find the area of the library. So the first thing that I'm going to do is draw the center of this polygon and drop a perpendicular or an apothem. I need to find that. So if you think about a triangle in an octagon, if we were to divide this octagon into a bunch of triangles, I could take 360 divided by 8, and that would give me this angle measure. So I know that this angle measure is 45 degrees. So, and again, I did that by taking 360 and dividing it by 8. So if that angle measure is 45, that means that the measure of the bisected angle is 22.5 degrees. So now stay with me. So here's what I know. We're going to have to do some trig. Well, we have two choices. We can either trig it, because remember the radius is 23.5. So we can either trig it, or we can use the Pythagorean theorem. So if I do the Pythagorean theorem, I know that this whole base right here is 18. That means that this is 9. So that would be a squared plus 9 squared must equal 23.5 squared. So a squared has to be, actually I just did all of the math. I didn't put the middle step. So a equals 21.71. Now if I want to use trig, knowing that this is 22.5 degrees right here, I could say that and I'm trying to find a, so I could say the cosine of 22.5 equals the adjacent over the hypotenuse. Now, it doesn't matter which method I use, whether I use trig or Pythagorean theorem, I'm going to be pretty close. I recommend that you always get your answer to 2 decimals, 2 decimal places. So I would carry 2 decimals, especially if I'm rounding to the nearest tenth. If I'm rounding to the nearest hundredth, I would make all of my working decimals be to the thousandth. All right, so now I've found my apothem. I know that my apothem is 21.71. So I need to find the perimeter. Let's see, well, the perimeter of this shape, it's an octagon. That's 8 sides. Each side is 18 feet long, so the perimeter is 144. So the area of the polygon, 1/2, times the apothem, 21.71, times the perimeter, 144. So when I put 0.5 times 21.71 times 144, I come up with 1,563. 1,563.12 feet squared. All right. Is 12. All right, so number 4 and number 5 we're actually going to do tomorrow. Number 4 and number 5. I do want to, actually I'll do number 5 tomorrow. Number 4, I'm not going to actually work it out. I'm going to do that as well tomorrow, but I do want to give you some hints because you do have a question like this on your homework. So I am going to draw remember this triangle is a regular polygon, which means that all of the sides are congruent and all of the angles are congruent. So that's the first thing that I want you to remember about a regular polygon. So basically this is an equilateral triangle. So if each one of these are 60, when I bisect that, they become 30. But 360 divided by, if I were to draw a big old circle around here, right? 360 divided by 3 is 120, but when I bisect this, this becomes 60. So this is really a 30, 60, 90. So the short leg is 8. Well, what I remember about a 30, 60, 90, if you have forgotten, is that the short leg, also known as x, the long leg, x root 3, and the hypotenuse, 2x. So I'm going to leave you with that. Your homework is actually some problems from the old geometry textbook. I have scanned the pages and uploaded them into the module. And you have a submission sheet, a Google sheet to submit your answers. Alrighty, good luck.